Welcome to Module 4, PMI Training and Accessories. The requirement for positive material identification, PMI, of alloy materials in refinery systems and petrochemical plant operations has grown dramatically over the past 20 years. This requirement has been driven by the loss of plant equipment and production, along with loss of life, as a direct consequence of having the wrong material installed in a process plant. The new U.S. Occupational Safety and Health Administration, or OSHA, CPL 0300004, Petroleum Refinery Process Safety Management National Emphasis Program, is an example of the type of enforcement taking place worldwide as a result.
Let's talk about PMI best practices. The American Petroleum Institute, or API, has issued recommended practices called RP 578 as a guide to PMI best practices. This is at least partially in response to OSHA's implementation of the National Emphasis Program, placing the burden of documentation and training squarely on the shoulders of the refinery owners and operators. The API has previously published inspection codes for piping, API 570, pressure vessels, API 510, and storage tanks, API 653. More recently, API has approved an updated version of the API recommended practice, RP 578.
To certify or recertify API 578 inspectors in proper guidelines and application procedures utilizing XRF and optical emission spectroscopy, or OES, technologies from PMI, a 2-day course has been approved by the API. This course provides attendees with a thorough understanding of API RP 578 guidelines and procedures, as well as a practical hands-on experience with XRF and OES instruments. A 3rd day of field testing is optional. More information on API RP 578 training is available at api578.com.
Given the record of serious accidents and deaths in the petrochemical industry, OSHA is also conducting on-site inspections in the United States to assure that we're following best practices in PMI testing. To complement this effort, in conjunction with Analytical Training Consultants, or ATC, we offer a 2-day API-approved certification course. Additionally, we have developed a comprehensive turnkey PMI testing program. These new developments in technology and training are making it easier to perform PMI in more locations with greater accuracy, with better trained operators than ever before. The complete thermoscientific Niton Analyzer's PMI alloy testing system includes the latest advancements in Niton analyzer capabilities, plus refinery-specific testing accessories that augment the use of XRF, as well as extending the reach of the technology.
Examples of the incremental capabilities include
Weld Spot, a collimator that narrows the X-ray focus to isolate welds from the base materials.
CamShot, an internal CCD camera to aid in analyzer positioning and to document sample location for traceability.
Direct Read Electronic Position Indicator, EPI, data logging buttons.
Real-time GPS integration. Bluetooth wireless portable printer for on-the-spot hard copy documentation of tests.
PMI-specific certified reference materials, or CRMs. Hotfoot, high-temp shielding for use in testing of hot materials up to 850 degrees Fahrenheit.
Extend-a-pole XRF extension pole to reach hot or difficult-to-access areas.
PMI Standard Operating Procedures, Best Practices and Procedures document.
API-certified PMI training.
All specifically designed to provide complete assurance of data integrity under the most rigorous conditions encountered in our industry.
We will now go over the PMI kit and its use. The built-in weld spot provides small spot collimation for welds less than 8 mm in diameter. Weld spot focuses the X-ray excitation beam to a 3 mm spot size for isolation and analysis of welds or other small areas. Weld spot can be turned on or off depending on the application. The CamShot color CCD camera option always comes with weld spot. To use weld spot, select Test, then Tools. Under Tools, select Toggle Spot. To obtain optimum performance for routine PMI applications, be sure to deactivate this feature with the same toggle when your use of this feature is finished. The CamShot internal color CCD camera is integrated into the instrument for positioning of the analysis spot location on the sample and photo logging of sample analyses. To activate the camera view from main menu, tap the Common Setup icon, then Instrument Setup, then Hardware Setup. When this screen appears, select the camera box. A check mark will appear to indicate this mode is active. In the event you desire to save all camera images to the NDT file, select Save Image as well. To exit, select the Save button. Select Return twice to return to the main menu. When you enter the test mode, the camera image will appear on screen. The red circle indicates the focused 3mm spot to be centered on the desired sample area.
An example of the benefit of this feature can be demonstrated by measuring this 3mm fillet weld without the benefit of our 3mm weld spot and CamShot options. Here we see the incorrect call on this weld since the 10mm aperture takes in both the weld and the base material around the weld. Let's now activate the weld spot and CamShot features to allow us to easily isolate the 3mm weld from the base material for testing. Here now is the reading taken with weld spot and CamShot activated.
We now see a correct call for the stainless steel 13-8 moly. When we test the base material, we see it as pure iron or carbon steel. Any iron or steel containing only carbon as the alloying element will be identified as iron carbon steel to indicate that we cannot test for carbon, and therefore do not distinguish between pure iron and steel with carbon content.
The Electronic Position Indicator, or EPI, consists of the following components:
The EPI buttons for recording information,
the serial cable connector,
button link.
EPI button reader.
To use the EPI system, connect the cables to the button reader. The serial connector has 6 pins, and the button link connector has 4 pins. Plug the button reader fingertip extension into the button reader's second receptacle as shown. Plug the gray serial cable into the button reader's top receptacle and into the serial connector of the Niton XL3 analyzer.
To set up the Niton analyzer for use with the button reader, you will need to go to Serial Output. From the main menu, tap the Common Setup icon, then the Serial Output icon. From this screen, tap Printer, which will activate the output to the button reader. The screen will now look like this, with Printer active and Live Serial Output grayed out.
The printer output settings determine what information is sent to the button reader after the Niton analyzer does a reading. From the main menu, tap the Common Setup icon, then Instrument Setup, then Miscellaneous Settings, and finally Printer Output. From this screen, you may select Print Less Than LOD, optional, not saved to button, Print Complete, optional, not saved to button, Print Data Fields, required, Print Date and Time, required. To initiate a measurement, press the button reader gauge key, which is the 0 enter key, to wait for data. This starts a 120-second countdown for data capture. Press the analyzer trigger to start the reading. After you have measured for a sufficient period of time, release the trigger. When the trigger is released, the data is sent to the button reader. You will hear a beep from the button reader, and Niton Reading will appear indicating it is now ready to write the data to the button. The first 3 lines of the data are shown on the display. At this point, you can use the up-down arrow keys to view all the data sent to the button reader. Using the fingertip probe, touch a button to write data to the EPI button. The reader will display CMB reading. To cancel the data capture mode, press the delete key until Niton Reading appears on the display.
The following screen shows what is stored on the button reader: the date and time, the sample number, the ID, the data entered into the data fields, including the example here, and the result information, including the element, percent, and error.
To delete records on the button reader, press the 5 key, which will show a pop-down menu. The delete key will close the menu. The enter will accept the menu choice. The up-down keys will change the menu choice.
For one-hand operation, it is recommended that you clip the button reader handheld onto the analyzer holster. You can easily press the gauge key to capture the analyzer data. Normally, you don't need to look at the display. Hearing the beep should be sufficient. Once you hear the beep, you are ready to write data to the button. A retractable lanyard makes the fingertip button probe easily accessible. Simply pull the fingertip probe and touch the button. The compressed data will automatically be written to the button. A good beep from the button reader handheld indicates all went well. For more information on the EPI system, contact your local Thermoscientific Niton Analyzers sales representative.
Also included in the complete PMI kit is a suite called the PMI 15 kit, which is a set of 15 refinery-specific certified reference materials, CRM, alloy standards. These include common refinery alloys such as low alloy steels, the chrome moly steels, austenitic stainless steels, duplex stainless steels. These are useful for auditing and verifying analyzer performance.
Another option is a Bluetooth-equipped GPS for logging location coordinates into the EPI button. This can make relocating the buttons much easier. To use the wireless GPS with the Bluetooth-equipped Niton XRF analyzers, follow the Bluetooth connection instructions found in the user's manual to scan for and connect to a Bluetooth-enabled GPS device.
Once connected, the GPS unit sends out a number of signals that can be read. The analyzer will display the relevant information from the GPS after connection, as shown here. These coordinates can be viewed in the data screen in entry positions 8, 9, and 10. Scroll down to reach these fields. When the results are downloaded using the NDT software or EPI data button, the GPS coordinates are also downloaded.
You can also use Bluetooth barcode readers with your analyzer. There are two versions of wireless barcode readers, the scanner and the wand. Connect your barcode reader to your analyzer via Bluetooth, as described in your user's guide. Once the reader is connected, you can use it to input data into your analyzer.
On the data entry screen of your instrument, highlight the desired field. While pressing the button on the barcode wand, swipe the desired barcode. If the pencil successfully reads the barcode, it will beep. The barcode data will show up in the data field after the beep. There is a short delay while the information is being transmitted. You may also use the virtual keyboard screen to enter the barcode data. Please refer to your user's guide for more information on this accessory.
If you're planning to test materials that are at elevated temperatures, the following guidelines apply. Up to 400 degrees Fahrenheit or 204 degrees Celsius, no special considerations apply. In these cases, we recommend that you keep the measurement as short as possible, but consistent with good measurement practices. Typically, this means about 5 seconds, but no more than 10 seconds. If the temperature is above 400 degrees Fahrenheit or 204 degrees centigrade, place the analyzer into the hot foot jacket, which will allow operation with materials whose surface temperatures can be as high as 850 degrees Fahrenheit or 454 centigrade. When measuring samples at elevated temperatures, you must wear suitable protective equipment and follow all appropriate safety practices to minimize the risk of injury.
If access is difficult for the operator, the Extend-A-Pole accessory can be utilized. Place the handle of the Niton XL3 loosely inside the clamshell grip of the Extend-A-Pole. Plug the cable of the Extend-A-Pole into the remote trigger port. Make sure you plug it into the proper port on your analyzer, as shown here. Clamp the clamshell tightly around the handle of your Niton XL3.
Extension of the pole is accomplished by pressing in the button on the pole. Next, pull out the internal sliding pole until it is at the desired length. Then, snap the button into the nearest hole. You will also need to enable the remote trigger on your instrument by selecting the remote trigger checkbox on the hardware setup screen.
From the main menu, tap Common Setup, then instrument setup, then hardware setup. When this screen is displayed, click on the remote trigger checkbox to enable the Niton XL3 to interface properly with the extendipole. You can operate your Niton XL3 through the trigger of the extendipole as if it were the trigger of the Niton XL3. Using the extendipole, you can test samples distant from a catwalk, high off the ground over your head, and in difficult-to-reach areas.
In addition to the world-class analyzers and hardware, we also provide world-class documentation and training. Documentation includes the user's guide for analyzer, software, and accessories, as well as an industry-standard operating procedure for PMI testing, specifically written for the Niton analyzer.
Our PMI training options have also set a new standard in the PMI industry with the world's only API RP 578 PMI certified training course. This 2 or 3 day course can be conducted on-site or off-site. It is provided by API-approved Analytical Training Consultants, Inc. The course includes an API RP 578 PMI certificate and ID card, which is valid for 3 years, after which a recertification is required. If you would like more information, contact your local Thermo Scientific Niton Analyzers representative or visit api578.com.
For information on new application of the XL3TS Gold technology for analysis of residual element content of carbon steels in HF units, you may view the brief presentation comprising the last part of this module. Please contact your local representative for further assistance or additional information. Module 4.1, Residual Element Content. A new PMI application for the analysis of residual element content in carbon steel piping and welds has recently been developed for the Thermo Scientific Niton XL3T. This new capability is made possible with the improved detection limits now obtainable using the XL3T 900 with gold technology. Carbon steel piping and welds are utilized extensively in the HF hydrofluoric alkylation units that reside within petrochemical refineries. The Niton XL3T gold instrument can perform an in-situ analysis of 3 key residual elements found in carbon steels: copper, nickel, and chrome.
It has been determined that a combined concentration of 2,000 ppm or greater of these 3 residual elements will reduce the HF acid corrosion resistance of the carbon steel. Known as flow-accelerated corrosion, it occurs when the levels of these 3 elements are out of specification, possibly leading to catastrophic failure.
Since we have a combined LOD, limit of detection, of 600 ppm for the sum of copper plus nickel plus chrome with our high-performance Niton XL3T gold instrument, it can accurately determine whether total residual elemental content is greater than or less than 2,000 ppm. Total analysis time is 40 seconds for these elements. Even lower combined detection limits, 400 ppm, are obtained for longer analysis times, 100 seconds.
Limited sample preparation is required. The analysis area must be sanded clean prior to testing. The Niton XL3T Gold software will display both the separate analysis result for each of the residual elements as well as the combined sum of the 3. The software also has the ability to present a pass, less than 2,000 ppm, analysis in green, or a fail, greater than 2,000 ppm, analysis in red on the instrument display. Please contact Thermo Scientific Niton Analyzers Business Development Group for more information on this new application.